So the question we're going to be doing is an object with a mass of 3.95 kilograms travels in a horizontal circular path of radius 1.35 meters. The object travels at a speed of 175 revolutions per minute and is connected to a central rotating point using an aluminium rod with a diameter of 9 centimeters. In megapascals, calculate the tensile stress that the rod experiences. So before we do anything, it's going to be important to highlight all the key facts and figures, if you will. So that will be the mass, which is 3.95 kilograms, the radius, which is 1.35 meters, the speed, which is 175 RPM, the diameter of the aluminium rod, which is 9 centimeters. The megapascals, as that's what we need to convert it to from pascals when we finish at the end. And I'd also highlight that it's travelling in a horizontal circular path and at a central rotating point. Okay, so the first things first, I say the best thing to do is kind of work your way back. So we know that we need to calculate the tensile stress. So the stress is given as the force over area, and we've got the area, which will be the area of the aluminium rod. So we need to calculate the force that's acting. So the best way to do things next would be to draw a diagram so you can kind of visually see what's going on. And even if you don't get as many marks because your working out's wrong, you can still get marks for your diagram as you're showing that you understand what's going on. So we have the center, the aluminium rod. Then we'll have like a wire which is holding the mass, which is 3.95 kilograms. The radius, which is the radius of the path and not the radius of the rod, so it's 1.35 meters. And then we've obviously got the speed, which is 175 RPM. Now, a question that was asked on Peerwise, which also is linked to the theory, is why was the linear acceleration of the object used and not the angular acceleration? The object was moving in a circular motion. So, as the question is linked to the tensile force subjected to the rod at the centre, the force will be going down the length of the rod between the mass and the centre. So it uses linear acceleration as the acceleration, and the force is acting towards the centre. So you've got a force which is acting towards the centre. And then also, because everything's acting towards the centre, everything will be done centripetally. So the question could also have been rearranged and split down into three or four separate parts, where it asks for the centripetal acceleration, the centripetal force, the angular velocity. So that's another way the question could have been broken down from just one big 12-mark question to a 12-mark question made up of 3 and 4 mark questions. So then also, as it's a horizontal circular path, we know the mass will be travelling around like that. So it's going to be angular acceleration, angular velocity, that we need to calculate. So first things first, we'll calculate the angular velocity, as that's what we need to calculate the centripetal acceleration. So equals your RPM times 2 pi, which is a full circle, over 60, which is seconds, so that will give us our radians per second. So we'll do 175. Oops, just make sure the 5 is always clear, as you can also lose marks for not being clear, because if that looks like an S, they may think you're talking about 17.17S, and you can lose marks for unclear handwriting. And then that gives us 18.32591. Oops, not 5, not 1. 715 radians per second. It's important that we don't simplify any of the values until the final step, as I'll go through later. So now that we've got the angular velocity, we can use that now combined with the radius to calculate the centripetal acceleration. So that gives us, so it's A, remember it's linear acceleration, not angular, so don't get confused with this. Again, that's another mistake you can make, which can possibly cost you marks, as they're two different things in the way they act. Okay, so that's given as your angular velocity squared times the radius. So we just copy this. Remember to square it times by the radius, and that's the radius of the path and not of the rod, which is 1.35, which then gives us an answer of 453.3849524. Again, remembering not to simplify it. And now that we've got the centripetal acceleration, we're allowed to calculate that centripetal force. And then that's just simple as doing force equals mass times acceleration. Always remember to do your mass first, then your acceleration. Even if you did it the other way around, you still get the same value, but it's just when you're going through it all and double checking your answer once you finish the question, it's clearer and concise. So we've got 3.95 times times our acceleration, which then gives us a force of 1,790.870,562. Oops, remembering to add the units to each step as well, so it's clear what you've done. So meters per second, and then your force is in newtons. Now that we've got the force, to do this up here, we need to first calculate the area. So there's two ways of doing the area. You can either do it area equals pi r squared, or pi d squared over 4. Personally, I prefer doing pi d squared over 4 as when it's given in diameter like this question. So there's no conversions, you don't forget anything, as in a high intense environment like an exam. When you're sitting an exam, you tend to rush things and kind of skip steps, like that conversion from radius to diameter and vice versa. So that's why I prefer to keep it as diameter or as it's given. So we do pi times 0.09 because that's the conversion, so centimeters to meters. You can either do it as 0.09 or 9 times 10 to the minus 2 squared over 4, which gives us 6.36172512 times 10 to the minus 3. And then now, remembering it's meters squared, now we need to calculate the final step, which is the tensile stress. So that's just done by 1070.870562 over 6.36172512 times 10 to the minus 3, which gives us a final answer of 281,507.0641. Now that's not the final step. As it says, you need to calculate it in megapascals. If you were to just leave it like this, you'd lose a mark because you've gotten to the right answer, you just haven't finished the final step as it's asking it in megapascals. So then we just convert that. That can be done on the calculator using the ENG button, which then gives us tensile stress of 0.28 megapascals, remembering to add the units at the end, because that's another important step, because if you don't add the units, in some cases some examiners may kind of get lost about what you're talking about. Now earlier I mentioned why we shouldn't simplify anything as we're going through it, so and this is the reason. So if we were to do the last step again, but this time just to 2 decimal places, over 6.36 times 10 to the minus 3, it would give us 281,583.33. Now, as it's asking for it in megapascals, it doesn't make as much of a difference because you're only really looking at those first 2 values. But if it was just in pascals, you can see there's a difference. So the difference is 76.27 pascals. And as we're engineers and scientists, we like to be kind of precise with everything and making sure that we've got precisely what we need and we're not kind of halfway there. And then I'd recommend kind of going through it one last time, step by step, making sure you've done things that can easily be missed, and just going over it all, like for example remembering to square it, remembering that if you are using the radius in the pi r squared, that you've converted the diameter of 0.09 to radius, because that's another thing, again, in a high pressure situation that can kind of trip you up. And then it's a case of also remembering that it's in megapascals, and to have your final answer clear here. So you've got the symbol for tensile stress, and then you've got 0.28 megapascals. So it's clear and it's done step by step, so the marker can see, for example, right, you've done this, so for here you get maybe around 2 marks. Then this is another step that would get you maybe 2-3 marks. This here, another 2 marks. As there's a conversion in the area, you possibly get maybe 2-3 marks. So already by doing all of this, you've got 9 marks. Then another 2 marks here, which brings it up to 11. And then finally, just for the conversion, you've got another 1 marks, which gives you a 12 out of 12, which is, so this comes up to a 12-mark question. And as I said before, it can also be reworded as first part A, find the centripetal acceleration, part B, find the centripetal force, and then part C, calculate the tensile stress. So that's how the question can be broken down and simplified in